Why is the power of 0? Why is it equals to 1? What I'm saying makes sense is that why is it that whenever we raise any number to the power of 0, the result is always 1? Is it a postulate or a constant that we will always need to work with? Well, it's neither a postulate nor is it a constant. In fact, it has a proof, which is the purpose of this video. So let's show the reason why any number raised to the power of 0 or any variable to the power of 0 is indeed equals to 1. So we are going to be considering two different ways of proving this out. But first, let's start with the inspection method. So first, what do you notice in 2 raised to the power of 1? You notice that the result will be 2. 2 to the power of 2, the result will be 4. 2 to the power of 3, the result will be 8. And 2 to the power of 4, the result will be 16. 2 to the power of 5, the result will be 32. And this pattern will continue in that pattern, in that order. Now, what do you notice? Notice that the result of the preceding index can be gotten by just dividing the result of the preceding one by the base. What I'm saying makes sense is that we can get 16 by dividing 32 by 2. Similarly, 8 can be gotten by dividing 16 by 2, which is 2 raised to the power of 3. Then, definitely we can get 2 raised to the power of 2 by dividing 8 by the base, which is absolutely right. It's definitely work out. Also, we can get 2 raised to the power of 1 by dividing 4 by the base. If that is the case, since we observe that this pattern works perfectly, then to get 2 raised to the power of 0, that would have been 2 divided by 2, which would be equals to 1. And that is how it works. But let's see if this is truly right. Let's consider some other number. What about 5 raised to the power of 1? 5 raised to the power of 0, let's leave that for now. 5 raised to the power of 1, 5. 5 raised to the power of 2, 25. 5 raised to the power of 3, 125. 5 raised to the power of 4, 625. And these will continue like that. Now, 125 can be gotten by dividing 625 by the base. Similarly, 5 raised to the power of 2 can be gotten by dividing 125 by the base. Also, 5 raised to the power of 1 can be gotten by dividing 25 by 5. Then if that is the case, 5 raised to the power of 0 can be gotten by dividing 5 with the base, which is indeed equals to 1. Since this works out, then we can definitely say that any number raised to the power of 0 is indeed equals to 1. Now, what if the index is negative? Will this still work the same way? Let's see. Now, what if I have 2 raised to the power of negative 1? This is indeed equals to 1 over 2. 2 raised to the power of negative 2 is 1 over 4. 2 raised to the power of negative 3 is 1 over 8. 2 raised to the power of negative 4 is 1 over 16. And this continues that way. Now, what can we say about these results? You notice that the sign will change. Instead of dividing, it will turn to product, because we need to make sure we work with what works out for us. Now, to get 1 over 8, notice that we can multiply the bit by the solution. So therefore, 1 over 16 multiplied by the base gives us the result for the preceding index of 2. Similarly, 1 over 8 multiplied by the 2, which is the base, gives us 1 over 4, which is the result for 2 raised to the power minus 2. Also, 1 over 4 divided by 2 gives us the result of 2 raised to the power minus 1, which is 1 over 2. If that is the case, 2 raised to the power minus 0, which is the same as 2 raised to the power 0, will give us the result of 1 over 2 multiplied by the base, which is 2. And eventually, that is equals to 1. As you can see, it works for both positive and negative index. So definitely, any number raised to the power of 0 is eventually equals to 1. Now, if you find this a little bit bulky or too confusing to understand, let's consider using the other way method. In this case, we will be considering the indices concept. From indices, you know that when you have A divided by A, the result will be equals to 1. This is a normal algebra operation. But in indices, both these A's have an index. In fact, their index is 1. Now, this is a number line division. We can change it to a regular division. This is called a regular. This is number line. Now, from the quotient law of indices, when you have similar base to have an index, you can take one of the base and subtract the power. Then you can have a raised to power 1 minus 1 to be equals to 1. But fortunately, 1 minus 1 is indeed equals to 0. So definitely, a raised to power 0 will be equals to 1. Since a can be anything, then we can clearly say and conclude that any number raised to the power of 0 is indeed equals to 1. Now you know why anything raised to the power of 0 is equal to 1 in mathematics. Hopefully you find it helpful. Thanks for watching. See you guys in the next video. Bye for now.